Hello students, in this short lecture of chemical thermodynamics, I'm going to discuss first law of thermodynamics. Now guys, first law of thermodynamics is not something which is unknown to us. कुछ ऐसी चीज नहीं जो हमको मालूम नहीं है. The first law of thermodynamics will also called as law of conservation. So we know that the entire universe is made up of energy and matter. And what this law of conservation has to say, it says that energy can neither be created nor be destroyed, can be converted from one form to the another. So this is also one of the statement of first law, because first law is based on law of conservation of mass. So सबसे पहला statement ये होगा कि energy cannot be created, cannot be destroyed, but can be converted into another form. Second, the total amount of energy and matter in the entire universe will remain constant. Third, when one type of energy disappears, another type of energy reappears. So basically जितने भी law of conservation of energy के statements है वो सब के सब हम लोग इसमें include कर सकते हैं. Okay, when one of the quantity of energy disappears, exactly equal amount appears. ये भी एक law of conservation of energy है. The total amount of energy of the system and the surrounding will always remain constant inside the universe. So all these statements that belongs to law of conservation of energy is actually the first law of thermodynamics. So सब लोगों को ये दिमाग में note down करके रखना है कि first law of thermodynamics is nothing but law of conservation of energy. It says that energy cannot be created, cannot be destroyed, but can be transformed. The total amount of energy and matter in the universe always remain constant. When one type of energy disappear, equivalent form of another kind of energy appears. So that is simple to understand. For example, आप कोई भी example दे दो. For example, if I take a battery which has a chemical reaction inside and produces electrical energy, so moment you put a battery inside a circuit of any device, it will start working. मतलब chemical energy is converted into electrical energy. Simple. Same thing, hydropower plant or nuclear power plant which produce electricity, it can be converted into mechanical energy. Suppose आपने switch on किया, fan चालू हो गया, it's a mechanical energy. Or you can also transform into another kind of energy and heat. So basically, conservation of energy is actually first law of thermodynamics, because dynamic means flow and therms means heat. So flow of heat आपको हर जगह दिखाई देगा जहां पर energy conserve हो रही है, energy change हो रही है. So basically that is law of conservation of energy. Now we are interested in the mathematical equation of law of conservation of energy. So let us derive the mathematical equation for law of conservation of energy, or we can say the first law of thermodynamics. So we know that internal energy of a system can be changed by applying two things on it. कोई भी सिस्टम का आप इंटरनल एनर्जी दो चीज से चेंज कर सकते हैं. वी हैव स्टडीड इन द प्रीवियस लेक्चर दैट इज हीट एंड वर्क कैन चेंज द इंटरनल एनर्जी ऑफ अ सिस्टम. सो वी कैन से दैट द इंटरनल एनर्जी ऑफ एनी सिस्टम इज अ चेंज ऑफ हीट एंड वर्क. अगर आप हीट और वर्क अप्लाई करोगे, इंटरनल एनर्जी चेंज हो जाएगा एंड यू गेट अ new value of internal energy, but we cannot calculate exact value of internal energy, therefore we find the change in internal energy. So that comes to the first law of thermodynamics का mathematical equation. So we'll derive it now, the mathematical equation of first law of thermodynamics. और उसमें एक चीज समझना बहुत जरूरी है कि internal energy और work and heat are interrelated. For example, I'll give you an example in this. Suppose we take a tube consist of water, उसको आपने heat किया, and that metallic tube which has water in it is connected to a turbine. So what will happen when you heat that water from the tube? The heat is reached to the water molecule will convert into steam. The steam is nothing but high heated water vapors, so they will move with a very high speed. When the steam moves with a very high speed and pressure, they comes in contact with the turbine start moving, and the turbine is connected to the generator, and generator will produce electricity. तो सिंपल हो गया यहाँ पर कि जब आप हीट सप्लाई कर रहे हो वाटर को, तो वाटर की इंटरनल एनर्जी बढ़ रही है, ठीक है, वो स्टीम में कन्वर्ट हो गया है. उसके बाद वो टर्बाइन मूव करके वर्क करेगा, और वर्क करने के बाद यू गेट इलेक्ट्रिसिटी. मतलब finally there is a conversion of one form of energy into the another form of energy. मतलब heat से आपने सीधा electrical energy produce कर दिया. But इस process के अंदर जो water जिस system में था, the system was the water, the internal energy of the water will change. Okay, क्योंकि आप heat supply कर रहे हो. And you know the sign convention, when the heat is supplied to the system, the heat is positive. If heat is positive, Q will be positive, internal energy of the system will increase. If the heat is lost by the system, then Q is negative, internal energy decreases. Similarly, if the work is done on the system, then internal energy decreases. If work is done by the system, okay, work is done on the system, then internal energy will increase. And if the work is done by the system, the internal energy will decrease. So you know the sign convention, and you know how the internal energy is related to heat and work, जो मैंने explain कर चुका हूँ. अब इसका mathematical equation derive कर लेते हैं, जो बहुत simple है derive करना. It's very simple to understand the mathematical equation. So I'll write down here. Equation of first law. So what is the mathematical equation? So consider a system. You consider a system, a gaseous system with the initial internal energy U1. So this is the internal energy of this system. What do you do to this system, to the gaseous system? You supply heat. So heat is absorbed by the system. Okay. Okay, you supply heat. So now the heat is added to the system. So now the total internal energy will be U1 plus Q, the new internal energy. Now what do you do? On the same system, you do some work. मतलब work is added. The work is done on the system. तो मैं लिख देता हूँ. You do some work on the system. So what happens? The work is also added to the internal energy, because ये दोनों चीज ही internal change कर सकती है. So the new internal energy of the system U2 will be equal to U1 plus Q plus W. So what we can write down here, that U2 is equal to U1 plus Q plus W. Therefore, U2 minus U1 is equal to Q plus W. Therefore, delta U is equal to Q plus W. So this is the mathematical equation of first law. अब इसके साइन कन्वेंशंस हम लोगों को पता होने चाहिए. Okay, now we know that in case of pressure volume type of work against a constant external pressure, the work is written as minus P external delta V. So आप equation को ऐसा भी लिख सकते हो, delta U is equal to Q minus P external delta V, change in volume for the pressure volume type of work, which is in the irreversible expansion of gas. हमने जो पढ़ा था last lecture के अंदर. Okay. So this is the mathematical equation which you will use for numerical calculation. आप यही equation numerical calculation में use करोगे. अब suppose if I say heat is lost by the system, so heat becomes negative. So now the equation becomes delta U is equal to minus Q plus W. If I say heat is gained by the system, so heat is positive. मतलब delta U is equal to Q plus W, जो हम लोग equation use करने वाले हैं. हमेशा यही equation आप use करना. So if I say work is done on the system, the work is positive, so delta U is equal to Q plus W. If I say work is negative, मतलब work is done by the system, so delta U is equal to Q minus W. So you can have so many equations. अब ये दो को भी combine करके आप लिख सकते हो. Okay, if the work is positive, suppose if the work is positive and Q is negative, so it is minus Q plus W. If the work is positive, the Q is positive, so delta U is equal to Q plus W. So like that, you can have so many equations with respect to the different sign convention, what is written in your numerical and what is given. उसके हिसाब से आप इसको जज कर सकते हो. Okay, so this was the entire mathematical equation for first law of thermodynamics. I'll clear this up. And what do you need to remember? The sign conventions which I've written here, you need to remember this. Okay, guys, now I'll clear this up.